Alice must send a secret message to Bob. Alice and Bob must publicly communicate some parts of their messaging scheme. Anyone listening knows the following. A large prime P, typically over 70 digits long. We'll use a small prime P for this video. A field K of characteristic P. An elliptic curve such that the points on the curve with coordinates in K form a cyclic group denoted by E of K. A point P on the curve that generates the cyclic group E of K. Here's a plot of the group E of K that Alice and Bob agreed to. Information about how to add points in E of K. See the links in the description. Alice randomly selects the integer k equals 60 and keeps it secret from everyone. Bob randomly selects the integer d equals 258 and keeps it secret from everyone. Bob computes the point d times p, renames it q, and shares those coordinates with Alice, and thus anyone else who's listening. Recovering the integer d from the coordinates of p and q is the famously hard discrete logarithm problem for elliptic curves. Alice chooses some way to encode her message. She will convert each character in her message to its corresponding ASCII value and sum these. Next, she'll write this sum in base j, where j is the number of points in the group E of k. The points in the group E of k can be ordered lexicographically, where you first compare the x coordinates, then you compare the y coordinates. Using this ordering, Alice associates the mth digit in the base j expansion of her sum to the mth point on the elliptic curve. Thus, Alice has encoded her message as these specific points on the elliptic curve. Alice will now encrypt these encoded points on the elliptic curve such that only Bob can efficiently decrypt them later. The ElGamal Encryption function simply adds k times q to each encoded point pm. Alice sends Bob the coordinates of each encrypted point as well as the coordinates of k times p. Anyone could recover the encoded points by subtracting k times q from the encrypted points, but that's hard to do without knowing k. Bob is the only person who can compute k times q efficiently without knowing k. He simply scales the point k times p sent by Alice by his secret d. Now we'll see if Alice can get her secret message to Bob before it's too late.